Let me check. Since fine. So hello everyone. I'm Athav and we ran out of small problems. So we couldn't have the exact recording of the session. From tomorrow onwards, you will get the exact recording of the session. So I will just cover out all the stuff we covered in the today's session. So let's move further. Right. So first of all, we looked over the entire schedule of the boot camp. It would start with introduction, as today we did. Tomorrow we will be having a linear regression. In week 2, we will look towards logistic and decision tree. In week 3, we will look towards schemes clustering, that is a unsupervised learning model, and PCA, it is principal component analysis. Then we will also have a look over dimensional reduction to handle the large amount of data set, how to remove unnecessary stuff from that. So what all we looked in this session was we first of all looked what is artificial intelligence, what is machine learning, how to clone and fork, what is a IDE, and what is no, not what is. We also saw basic Python, right? Like NumPy and Pandas basic functionalities in that, right? So no need to worry regarding that stuff. I know he during cloning and forking you may have faced issues, so it's fine. Yeah, just look this recording once more. Hope you would get most of the stuff by looking at once again. Right. So let's move further. What is artificial intelligence? Basically, artificial intelligence is a complex structure where multiple things comes to picture like robotics. Basically, we just want to do a simple thing that is to mimic a normal human being. Right. So let's understand this small example. Let's take an example of self-driving car. So in a self-driving car, there are a lot many sensors working. There are cameras which detect the obstacles to avoid them, right? There are a lot many algorithms and programming questions working at the backend side, right? Isn't it? So this was an overview of artificial intelligence. Basically, artificial intelligence is the ability of a machine to imitate human behavior. In our example of self-driving car, basically we are trying to imitate a person who can drive car, right? Isn't it? So basically, we just try to mimic the human. The next thing is machine learning. Now, machine learning is a component or a subfield of artificial intelligence. Now, what is machine learning? Suppose there's a machine which tries to learn. Simply that machine is known as machine learning. That's why the word itself says machine learning. Right. So let's understand what is machine learning in much more deep and detailed way. So basically, machine learning is a subfield or an application of an AI that allows system to automatically learn and improve from experiences. What do you have to say from experiences? Like the thing is, suppose there is an IPL match, right? Uh, many of you must have seen Indian Premier League. I hope you can just expect any other similar match, right? So, for example, there is a match between two teams. Now, how a machine learning model can predict which team will win? It will try to look out the previous year's data that on this pitch, which player played well, right? So it tries to understand the data, the previous data, and tries to learn on top of that. Simply, this is work of machine learning algorithms. So we will learn this technique of machine learning algorithms in much more detail further. Let's talk about deep learning now. What is deep learning? Yes, deep learning is a field of machine learning, but in machine learning, we are trying to solve a problem. Deep learning is also solving the same problem, but in more accurate way with more precise and good result. I hope you all guys got the by deep learning. And what is the difference between machine learning and deep learning? You can say deep learning is a subfield of machine learning or application of machine learning that involves the use of neural networks to model and solve complex problems. So now you must have you must be facing small issue regarding what are neural networks. No need to worry regarding that. Most of you must have heard regarding nervous system. We all actually study nervous system, right? So how a nervous system works, their dendrites comes to picture, their axon comes to picture, and a neuron which passes the message in a form of electrical impulse that comes to picture. So this stuff I learned in my early 10+2 or 10th grade classes, right? So not too early regarding that stuff. So what deep learning does is it tries to mimic the human nervous system, tries to act like that, and tries to solve the problem using that technique of how nervous system works. Simply, so we will not dive much more deeper into deep learning. If you guys want, then we can have a bootcamp related deep learning soon, but we are going to focus towards machine learning now, right? Many terms in the field of AI are actually revolving around deep learning. Like you must have heard regarding generative AI, natural language processing, large language models. Now, recently we saw LangChain coming into picture, right? These were the examples of deep learning. Don't to worry regarding the stuff. There were many things, and there are many things, right? So let's move further. Now you all got an intuition that what is machine learning, deep learning, and artificial intelligence, right? But what is but what type of problems it is solving? So I hope you all guys must have used Amazon. Okay, if not Amazon, like Google Maps. I gave the same example to this session, right? So what happens in Google Maps is whenever you post a negative feedback for a firm, it is never showed on the top to any of the other person, right? It will only shown to you. Why? Because the Google Maps identifies the text, whether it is positive, negative, or neutral. So their sentimental analysis comes to picture. What exactly it does is it is given a certain text, which is your feedback. It tries to identify it is positive, negative, or neutral. If it is positive, it will be shown at the top. If it is neutral, it's fine. It may be shown. If it's negative, it will be never shown. Simple. It will be never shown. So what type of data you are working here with? You are working with text. You are trying to identify this keywords like fantastic. Okay, I guess useless, right? So what the thing is, this type of problems are basically known as text classification problem. You try to classify the text in what? In positive, negative, or neutral. Simple, right? So let's move further. Similarly, let's try to understand this with a small example. There is a lane with 5 houses. And there's a lane with 5 houses. You know the prices of these 5 houses and why the prices are kept like that, that due to its square foot area, number of rooms, crime rates in the area. You know that data, right? Now, what you are told is there is a sixth house in the lane, and you are asked that what is the price. So you will have a basic estimation. How? You will try to calculate number of rooms, crime rates of the area. You will try to calculate the square feet area, right? On this basis, you will judge. So this type of things are also done by machine learning. It can predict the exact price too. Uh, you may say that machine learning are a set of techniques which uses statistics at the background to solve certain problems, like statistics like you may say mean, mode, median, and probability also comes to picture. Not statistics, but probability also. You can see that in naive Bayes. Fine. So this type of problems are known as regression problems. We are going to look towards regression problems. Tomorrow only we will start with that. So what next? Now here comes Pokemon. So the first one is Bulbasaur, the middle one is Pikachu, and third one is Charmander. Now I say we have a folder. In that folder, we have 100 images of Bulbasaur, 100 images of Pikachu, and 100 images of Charmander. Now, what our machine learning algorithm will do, it will try to identify some features. Features like eyes, features like green color, like this lotus type back. It will try to identify fat tail of Pikachu. It will try to identify fire in the Charmander. So whenever a new image is shown, it will try to compare these features with the new image. Is there any fire symbol? No. Is there any fat tail like Pikachu? No. Is there any lotus? Yes. So it must be Bulbasaur, right? So this type of problems are basically known as classification problems, image classification problems, because we are dealing with images, right? So this is an image classification problem. Now to solve this type of problems, we have two techniques, right? The first one is supervised learning. The second one is unsupervised learning. One more technique we have in machine learning, that is reinforcement learning. So we will look towards reinforcement learning. First of all, let's understand what is supervised learning. So basically, when we talk about supervised learning, we have a data set. We from start of the session we talked about there is a data set, right? On that previous data, our algorithm tries to learn something. Now, what if I say the data we have is labeled? Labeled means what I want to say key. Here our data set was labeled. Each and every images were labeled with their name. Like there are 100 images, the 100 images were of Bulbasaur only with a name Bulbasaur, right? Similar with Pikachu and Charmander. So here we know that our data is labeled, right? But what if data is not labeled? Like in this, we have 400 images. We don't know which is Bulbasaur, which is Pikachu, and which is Charmander. What we will do at that movement is we will try to identify green images. We'll make one cluster. We will try to identify yellow images. We will make one cluster. We'll try to identify Charmander, like orange color. We will make one cluster, right? Because we don't know that Charmander is a Charmander. We just know that there is an enemy which is of orange color. That is cluster 3, right? So at that movement, we have unlabeled data. So when we handle this unlabeled data, then unsupervised learning comes to picture. The best example of supervised learning is, let's see. So the input is 1, the output is 1, the input is 2, the output is 4. So we are just querying it. You can guess what is the output for 10. Obviously, it is 100, right? So here, what happened? We had the input, we had some input, we had the labeled input, we know 1, 2, 3, 4, 5, 6, 7, 8, right? So it is supervised learning. But what if I say that there's a pack of balls and you want to identify how many green, blue, and red are there? There is a robot who don't know what are the colors. He just know okay, there are balls, 25 balls in a bag, and now your machine learning algorithm want to identify that how many are red, green, and blue, right? So the robot doesn't know how yellow looks, how red looks. Algorithm is going to predict by its own. So we don't have a labeled data. If in this case the data would have been labeled, then it would be red ball 5, green ball 6, and yellow ball 3. So like this, the data will be labeled, right? Each and every ball will be assigned with a color. I hope you got an intuition of what is supervised or unsupervised learning. We looked over attributes, we looked over features. We say that we saw that fat tail is an attribute, eyes, color, each and everything which distinguishes from another enemy is a feature, right? So let's focus on reinforcement learning. What is reinforcement learning, guys? So basically, in reinforcement learning, we try to create an algorithm which learns on rewards. What are these rewards and what are these punishments? Now you need to understand. Okay, so let's understand that. No need to worry. So let's take an example. There's a dog. Whenever I throw a ball, he goes and brings that ball back. Whenever he goes and bring that ball back, I reward him with a toffee. And whenever I say him to sit and he doesn't sit, so I will not reward him a toffee. So in second case, where I'm telling him to sit, he's upset because he's not rewarded with a toffee. In the first case, he just gave the ball, so he's rewarded with a toffee. So whenever I throw the ball, he will bring the ball. Whenever I will say is to sit, so he will not sit for the first 2 to 3 times. But what if? But what will happen fourth time? He will sit. Why? Because I am telling him, and fourth time I will give him toffee. So after that, he will always sit whenever I say him sit. Right? So this is an example of reinforcement learning. It is a model which learns on rewards and punishments. Fine. So there are few buzzwords in AI. These buzzwords are like machine learning. We saw that deep learning. We saw that computer vision. What is computer vision? Simply giving a machine the power to visualize the things. Giving a computer the power to visualize the things, you may say. Right? Like advanced CCTV solution is the best example of computer vision. You must have also seen that through cameras, whenever you go against any traffic rules, challan comes directly to your mobile number, right? How it is happening? Just because of the use of computer vision. The camera and the server get the access of visualization. It visualizes the images, captures the images, then machine learning algorithms are applied on it, and boom, it gives the result that you have not followed the traffic rules. Simple as that. Then next is natural language processing. So basically, whenever you try to understand human language, maybe Hindi, Marathi, English, so that stuff comes in natural language processing. You must have heard terms like large language models. ChatGPT, generative pre-trained model. It is the best example of natural language processing. So the next is automatic speech recognition. What is speech recognition? Whenever you speak something in front of Google Assistant, so it tries to understand that what you are saying, right? If you say hello Google, so it will reply, hey, how are you? Right? So why is this happening? Because it has recognized that you said hello Google and Google is his name. Simply. So this is ASR. Similarly, reinforcement learning we saw. I guess you got familiar with these buzzwords. There are few more buzzwords in the market like generative AI. You must have seen the QR code, right? The QR code which we have used for marketing. Actually, it was the best example of generative AI. We have created it using stable diffusion. So that this was his theoretical portion, guys. Now let's do one thing. Why not to move towards the practical approach, right? So what you have to do is just simply go and search for GitHub here. This would work and just tap on GitHub and just do a thing from here. You just go to your repositories and from that stuff, when you will come to repositories, like this is your own profile, right? So whenever you come to your own profile, you may see there is machine learning bootcamp. Just open this. Okay, I guess. Okay. As of now, just forget this all stuff, right? So just go and search for GitHub. Once you open this GitHub, just search for my name, that is Atharv LODE. Otherwise, you will get the link in the chat box, WhatsApp chat box. The one who have missed it. So just in the repository section, go to users section. In that, open the user. Once you open this user, go to my repositories and you will see a machine learning bootcamp repository, right? I hope it is visible to you all guys. So what basically you have to do is you just have to tap on the fork, right? And you have to fork this repository, right? So guys, I have done this before, so you are not going to see it, but no problem. Here you will be asked to write a name. So keep the name same and here a button will appear that will be create for. Just tap on that. Now, once you did this, you just go to your profile, like this is your profile. And in your profile, just move towards the repositories section. You may see machine learning bootcamp popping up. You may see, or if it is not visible, no issues. Just take a screenshot and post it on the WhatsApp group. So once you open this, now guys, what you need to do is just open this. You may see it is visible, completely visible, isn't it? Right. So what else stuff we are going to do now is we will just open the Edge browser, and after opening the Edge, it is not necessary to open Edge. Any tab will work. You just have to search for Google Colab. Anything will work, guys. Like I don't have any sort of issues. So whenever you open Google Colab, now what you have to do is simply my Google Colab is open. Just sign in from here. You must be asked to sign in with a profile. So select the mail with which you have created your Gmail account. It would be good. Not necessary. So once you open this, just cancel it out from here. So I guess you just opened your Google Colab, right? Now just go to file section and then just go to open notebook and you may see your option named GitHub here. So whenever you open this, an authorization option will come, just authorize that. It means you are giving your GitHub access to that. Right, so my GitHub access is now completely opened in Google Colab. From here, what you have to do is simply search for the name of your bootcamp. Okay, I got that. Great. Now, once you open that, just open the week 1, day 1 IPONB file. Right. So something similar interface you should see. Just tap a connect here. And guys, now we are diving deep inside handling basic Python on Google Colab. So you can use whatever IDE you prefer, like you can use VS Code, you can use Code Spaces, you can use Jupyter Notebook or anything else, whatever you want. So simply when you come here, now just write simple print. Uh, Just keep on checking my spellings. I'm very bad at it. So just hello bootcamp will work, and just you can run the cell from here also, or just enter shift enter, and it will last run anyway. No issues. You can run. Okay, it is running now. Now let's move further. Basically, now what we are going to look towards is NumPy. What is a NumPy? NumPy is a number array in Python, right? So many folks also find it difficult because but they also ask me question that why not a list? So let's make a list and try to understand what the problem is. Why not a list? So we will just create a list. The list will be of 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are all 9 numbers, and what? And just print the list, shift enter, right? So our list is printed. So let's move further. Now what I want to do is I just want to square these terms. Like 1 square is 1, 2 square is 4, 3 square is what is 3 square? Anybody? It's 9, guys. 4 square is 16, and so on. So what we want is we got this list, right? Now we just want to square this, and we want to ask that how long time it takes to square it, right? So what we will do, we will just write simple time it. Okay, Google Colab want to help us. So we will just write time it to identify the time, how long it takes to square the term. So I into 2 to square, and now we will use a loop that is for I in list. So what basically our code is doing, we are basically multiplying our I 2 times, I into I, right? Basically, suppose I is 2, so what will be its answer? 2 into 2. Basically, I is 4, so what will be its answer? So 4 into 4, right? So how many times we are doing? We are doing for each and every element in list. Okay, so just shift enter and check how long does it takes to do this thing. So it almost took 3.29 microseconds. Fine. Now, should we do the same thing using NumPy and identify why NumPy, why not list? So just install the numpy, that is pip install numpy and shift enter. Now it will automatically install the numpy, and it says requirement already satisfied. That means I already have that. Guys, by the way, why we are using this exclamation mark is just because it is a terminal command. Something like you must have worked regarding work with npm, that is node package manager. So you write npm install, so npm init. So basically it does the same stuff, right? So what we will do, we will now import this numpy at as import numpy as np, and just hit a shift enter. It worked. It worked, guys, right? So what we are going to do is the same thing which we did here, like time it, and now the stuff is quite simple. Okay, we missed out a thing. We will create an array. Array is a data structure which holds numbers. So actually NumPy is used to deal with that in Python. So what all stuff we are going to have here is numpy dot array. Basically we will tell, and we will insert all the lists inside it, and we can visualize it once. So right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So is it same? 1, 2, 3, 4, 5. Yeah, it is same. So our list is now inserted in the array. Now what we will do is we will just print the time. We will just print the, okay, just a second. What we will be going to do? Acha, we are going to print the time, right? Time, basically time it, and how long it does it take. So just imagine how simple it is to do this stuff in NumPy, using NumPy. So just imagine. So just hit shift enter. So it will give you the time taken to execute this small thing to square the terms. So it took 778 nanoseconds. Guys, nanoseconds is too small compared to the milliseconds, right? So NumPy is actually completely fast because it works more closer to the hardware. So why not to look more such things like let's generate some random numbers. what are these random numbers? Like random numbers, uh, random dot rand int, and this number will be bigger from 10 and smaller from 100, and its size will be how many numbers, guys, we want. Let's have it in row into column format, like 5 rows and 6 columns, and it should work. It should work pretty well, I guess. It worked. So okay, we haven't printed it, right? So just print. Let's print it. So okay, so this is the array created using NumPy. So guys, this was all about NumPy. If you want to learn more such things regarding NumPy, so just simply go to this and write NumPy in NumPy for Python. You can get all the stuff in the official documentation, that is numpy.org, or you can also ask for a cheat sheet globally. There are many stuffs available, like wherever you move towards the image, you get this stuff. Is it like, yeah, you got it. XCSV node 8. So you may practice these functions if you want. Completely optional thing. We are going to tell throughout the bootcamp, but you should be familiar with using this stuff, right? So the next thing we are going to say is what is pandas. Anybody who knows what is pandas? Let's install it first. If install pandas, so it said it's already installed, right? So let's import it. Like basically import pandas as PDP. Just a second. We are facing some issues. No. So simply pandas as PD, and now basically what is pandas? Basically, thing guys, as NumPy was a library, pandas is also a library which is used by data scientists mostly to, because it helps us to manipulate the data. Which type of data? The data which is stored in a tabular format, right? For example, there may be a Excel sheet data, or this data is also in tabular format. Like these are rows and these are columns, so it is also tabular format. Let's see this with an example, like how to read this data and how to print this data. So what we will do is we'll store it in a variable called df. So pd dot data frame, right? So are we making a mistake? Okay, D should be capital data frame, and here mm, what the stuff is data, which is equals to what, array one was it name? What was it name? Its name? I guess it's array one. So it should work pretty well. If it works, then it's completely fine. Okay, we have forgot to print this df. So let's just print this df. Great, it has been printed. Great to hear from your guys. Right. So this was basically about pandas. So that's all. That's all about basic Python. So I hope guys you all will try to understand this NumPy, practice this pandas and NumPy. Basically, NumPy will be needed much more. So just go to file section from here and just download this file in your personal computer. Download the IPYNB file, right? Once you did this work, now you need to do is just open your GitHub profile. In that, this machine learning bootcamp repository should be open. Go to week 1. Then in week 1, go to day 1. In this day 1, just go to here, go to add file, and just select hit a upload file. Okay, don't upload here. Just a second. Do this stuff inside this submission folder, right? Because you all are submitting. So go here, add file, like upload file, and just drag and drop, or just select that file which you downloaded. In my case, it was day 1, and just open that. And once you did that, go here and select, just write a commit, that is submission to semicolon, and whatever your name is, like my name is Atharv, and I'm just posting it on. Right. So just hit commit changes, and once you did this, it is done. Right. So it says the branch is 3 commits ahead, right? So just tap on it. Once you tap on it, you will see an option of new pull request. Just tap that option, guys, and generate a pull request, right? Blindly generate a pull request. So that's all. That was all about cloning and forking. So I will basically reviewing this entire stuff. I will be saying that what all you all guys have submitted, and the person who will have all the submissions, like each and every week's submission, he may be get a chance to get the LinkedIn premium for the entire year. So that's all, guys. That's all here. We close the entire session. I'm completely sorry for that I was not able to give the exact recording of the session which we had today. So I recorded this session for you all guys so that it can help you all a lot. And yes, that's all from my side. Thank you. Have a nice day. And you can use this stuff completely. Fine. Great.